Okay, here's our situation. We've got energy, but we're going to have energy as well as kinematics. So what I've done is I've just created a situation where I can do that. And what I'm going to have is I'm going to have this tow truck here. This tow truck is going to be applying a force of 5,000 newtons. And what that 5,000 newtons is going to do is it's going to move this car, which is going to be 3,000 kilograms, and it's going to move it from, here let's get some values written down. It's going to take it from an initial velocity of 0, so the car is at rest initially, and it's going to accelerate. It's going to cause this car to accelerate at 2.5 meters per second squared. And we're going to do it for 5 seconds, which means that you're going to end up with a final velocity, and I'm going to mess you up here by putting it as 45 kilometers an hour. And what I'd like to do is I'd like to know the amount of work that's done by this truck. Notice we don't have any information about the truck other than the fact that it's producing 5,000 newtons of force on the car. We want to know the work done on the car. Okay, so here's what we're going to do. We're going to look at our work equals force times distance formula. Notice that this thing is horizontal, so I don't have to go F cosine of theta. And if I look through my list of information that I don't have a distance. So I'm going to have to use kinematics to find that distance. So that's my first step. Find the distance. I can do it in any of the kinematics formulas that I'd like. I'll do both of them for you. But I'm going to use D equals 1/2 VI plus VF times T. The initial velocity is 0. Final velocity is 45 kilometers an hour. I have to convert that to meters per second. It ends up being 12.5. And my time frame, it occurs over 5 seconds. So when you do this, you get 31.25 meters. Okay, that's how far this truck pulls that car in 5 seconds. You could have also gone D equals VIT plus 1/2 AT squared. Your distance, you're going to get VI 0, 1/2, accelerates at 2.5 for 5 seconds squared, 31.25 meters. It doesn't matter which kinematics equation you use, you're going to get the same value for your distance. Now, I found my distance. I know my force. Where is it? Oh, it's up here, 5,000 newtons. So I want to know the work that the tow truck does on the car. Work is force times distance. Force is 5,000 newtons. Distance it occurs over, 31.25 meters. Multiply that all out, and you are left with a value of 156,250 joules. So there, that's the amount of energy that it takes that truck to move this car 31.25 meters. There.